Welcome to my video on scientific notation. So scientific notation is a compact way of writing very large or very small numbers. So this is a review of something that we covered in 7th grade. So a number written in scientific notation has this form, where a is just a number times 10, and n is an exponent, so 10 to the nth power. And what we have to keep in mind that this beginning part has to be greater than or equal to 1 but less than 10. So that's what this means here. Okay, so this means a is greater than or equal to 1, but it has to be less than 10. Okay, so converting to scientific notation, we're going to move the decimal so the new number is between 1 and a number up to 10. Okay, then step 2, we're going to write using a power of 10, and the exponent matches the number of times that the decimal was moved. Okay, so we're going to scribble this out so we don't get confused. And I'm going to tell you when the exponent is going to be negative and when it's going to be positive here. So when it's in standard form, okay, if the number in standard form is greater than or equal to 1, the exponent will be positive. And we're going to put this in capital letters so it stands out. And then if the number in standard form is between 0 and 1, the exponent will be negative. And if you haven't had enough time to write all that, just go ahead and pause the video because I'm going to erase this so we can look at some examples. Okay, so let's look at example 1 here. Okay, so what we're going to do here is start from the decimal. And notice there's not a decimal in this number, so we start right here. This is where the decimal would be. We just don't say 540 decimal. So we're going to start here, and we're going to move it until we get one number to the left of my new decimal right here. So we have 5.4, and 5.4 is greater than or equal to 1, but less than 10. So we are going to write my root number right here without any zeros at the end. So times 10, and because we moved 2 places, my exponent is going to be positive 2. Okay, and we know it's going to be positive because this number right here, the standard form number, is greater than or equal to 1. Okay, so let's look at it. Let's skip down to number 3. So once again, we're going to locate our new decimal, and we can count as we go. 1, 2, 3, 4. I'm still not there. 5, 6. Now I got one number to the left, so we moved 6 places. Okay. So remember that. And now I'm going to write my root number. And I'm going to drop the zeros at the end, so 1.852. And because we moved 6 places, we're going to say times 10 to the 6th power. Okay, let's look at another example. So we're going to start right here. There's no decimal. So we start at the end here. And we're going to go to our new position. 1, 2, 3. So our new position is right here. We have one number to the left. And we're going to, we moved 3 places, so we need to remember that for our exponent. And we're going to write 4.671 because I don't have any zeros to cut off here. We don't have any zeros to drop at the end, or the beginning for that matter, which we'll learn in a second. So it's times 10 to the 3rd. Okay, so notice all of these examples had positive exponents because the standard form number was not between 0 and 1. Okay, but now we're going to look at some examples where the standard form number is between 0 and 1. So look here, number 7. Now, we said we need to start from the decimal, so we're going to start here, and we're going to go to our new position, and we need to make sure that we have one number to the left of my new position. So one number other than 0 right here. And we move 2 places. Okay? So remember that. And we're going to drop our zeros in the beginning here. So we're going to say 5.273. And now we're going to write times 10, and this time we move 2 places, but it's not positive 2, it's negative 2 because this standard form is between 0 and 1, so we need a negative exponent. Okay, now let's look at number 9. Once again, same thing. This is between 0 and 1, so once again we know we're going to have a negative exponent. So let's start at the decimal, and we moved 1 place here. Okay? So we're going to write down our root numbers, so 2.58. Notice I cut off the zeros in the beginning here because we don't want to start with 0 in our root number, and we don't want any zeros at the end of our root number as well. So times 10, and we moved 1 place, so our exponent here is negative 1. Okay, now let's look at some examples of determining if the number is written in scientific notation correctly. Okay, so we need to make sure that our root number here has one number to the left of the decimal. Okay, and that means that it's greater than or equal to 1, but less than 10. And it's times 10 to a power. So this one is correctly written in scientific notation. Now look at this one. I have 2 numbers to the left of the decimal here. So this value right here is not between 1 and 10. It's actually greater than 10, 11.4. So this is a no. Now look at 13. I have 2 numbers to the left of the decimal, and I only want 1. So this is going to be not between 1 and 10. So this is a no. And then look, I have 1 number to the left of the decimal. So this value right here, 6.7, is greater than or equal to 1, but less than 10. So this is a yes, written in scientific notation. Now, I'm going to show you how to go from scientific notation back to standard form. Okay? So we're going to basically undo what we just did. So we're going to go the other way. So converting the standard form is even easier. The exponent tells you the direction and the number of places to move the decimal. Okay, so let's look here, and we're going to start from the decimal, and we're going to look at the exponent. So here the exponent is 3. So we're going to start here and go 1, 2, 3. And every time we move and there's nothing there, we are going to drop in a 0. So here I'm going to drop in 1 0. So I'm going to write 6380. Notice the decimal is no longer there because I moved it to the end. And remember, we don't say 6,380 decimal. so we don't need to put it at the end. Can you put it there just so you know where you moved it to help you out? Certainly. Okay, but it doesn't need to be there. And remember, we use commas, so 1, 2, 3, comma. So this is 6,308. Okay, let's skip down to number 17. So the exponent is 1, so we're going to start from the decimal. We're going to move it one place here. So now we moved it between the 8 and the 2. So I'm no longer going to write it here. So we're going to say 98.2, so or 98 and 2/10. Okay, let's look at a few more examples here. So we're going to skip down to 19. So 19 says 8.21 times 10 to the second, so 8.21 times 10 to the second. So we're going to move it 2 places. So start at the decimal, 1, 2. It's at the end of the number, so we don't have to write it. So it's 821. Okay, now let's look at some negative exponents. So we're going to skip down to 21. So now we're going to start at the decimal, but this time because it's negative, we're going to move this direction. So we're going to put it right there. And now I have to write it because it's in the beginning here. So 7.7932. And I can put a placeholder here if I'd like, or you can certainly leave it 0.7932. Okay? And number 23, let's try this. The exponent is -9, so we're going to start from the decimal, and we're going to move it 1, and now I've got to go 2, 3, 4, 5, 6, 7, 8, 9, and put the decimal right here. Now, I had to move 1 around the 2, and then I fill in 0. So I have to get 8 zeros here. It's not 9 zeros because the exponent is 9, because I had to move around that 2. Okay, so make sure that you have 8 zeros here. And I do. So I'm going to write it as decimal 0, 0, 0, 0, 0, 0, 0, 0, and then 2, 4. And notice I don't have it between the 2 and the 4 anymore because I moved it right here. Okay, so that's sometimes a mistake that students make, so be careful. And I could drop a 0, but I'm just going to leave it to show you that this is an acceptable answer as well. Okay, now to compare numbers written in scientific notation, you can just look at the exponent. And all of these numbers here are going to be written in scientific notation. Now remember, you can only use that trick if they're both written in scientific notation. If they weren't, then you would have to convert them both to standard form and then compare those values. Okay, so because they're in scientific notation, look at the exponent, 3 compared to 5, and I know that 3 is less than 5, so I put a less than symbol. Notice what direction the less than symbol points. Okay, now, once again, scientific notation. So I look at the exponent, and 7 is greater than 4, so I put a greater than symbol. 27, I have -2 and -3. Now -2 is greater than -3. Think how negatives work. And I put a greater than symbol. So notice the greater than symbol is pointing this way. And then the final example in this section, we have -6 compared to -1. And I know that -6 is less than -1. So this is a less than symbol. Okay, now application. So the length of one cycle of a visible light wave is this long decimal. I'm not going to read it in seconds. Write this number in scientific notation. Okay, so what we are going to do is, remember before, we're going to start at the decimal. Okay, and then we're going to go until we get one number other than 0 to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm still not there. 15. I have to go all the way here to get one number to the other than 0 to the left of the decimal. So this is 2. And now we have to write the exponent. We know we moved 15 places, and so now we've got to think about this. Is it negative or positive? And hopefully you are thinking negative, because right here, when the zeros are in the beginning, or another way of looking at it, when the value is between 0 and 1, you know it's going to be a negative exponent. So that concludes our video on scientific notation. I hope you have a great day.